Looks like it's filtering through. 3, 2, 1. All right. Looks like it's working. There's something in the middle of your screen. Looks like you're muted too. Cool, that's better. Even if there's a delay, it's better than having no picture.
All right, what's up?
Because I don't think I don't think there's Can you guys see us? I'm just waiting for somebody to
Yeah, I have it open on another tab. It was throwing me off because I was hearing you talk twice.
Oh, okay, cool. Yeah, so it doesn't look like the delay is too bad. So even if your webcam does show up at the door while we're doing this live stream, I think this will be just fine. Did you?
Awesome. Hey guys, how's it going?
Oh, hey, cool. Hey, everybody. Is the volume good? Origami Cybertruck, what up? I'm not sure how long the delay is. It looks like it's probably about 5 to 10 seconds. Sweet, volume is good.
Cool, I just got a volume is good. Yeah.
Sweet. Well, this went a lot more smoothly than I thought it was. Because basically, I'm running Zoom, and then I'm picking that up through OBS Studio, and then pumping that through YouTube Studio. So it's going through like 3 different layers. So it's just a matter of killing about 10 minutes while we wait for everybody to show up.
Yep.
Did you look any further into what is it? Lithium metal cell? Not lithium metal. There's a battery.
Yeah, it's lithium metal air. Yeah. So it actually funny you ask, because about an hour ago someone posted on the Tesla investors subreddit,
mm-hmm.
and it was an article talking about the patent that I was telling you about.
Yeah.
And it was pretty funny because I was kind of mad because I was like, no, I was going to talk about it tonight.
Well,
it's all good.
It'll go ahead. I interrupted.
Oh yeah. So basically, if you just have oxygen, like just the theoretical specific energy of the reaction between lithium metal and oxygen, just the pure interaction between those two things, the specific energy is 13,000 watt hours per kilogram, which is literally like the same as gasoline. Now, when you start, that's irreversible. There's all these things that you have to add on to that. Once you do instead of a primary battery, you do a secondary battery, which basically means it's rechargeable. Once you do that, it will fall to like 3,000 to 1,000, and then to extend cycle life, if you do a couple other stuff, and it drops it down to basically, in the lab they've been able to do 800 watt hours per kilogram for these lithium metal air cells. And the interesting thing about this is basically the reason why I bring it up, for those who in the chat, Tesla's been filing patents for this technology since 2008. So they've been looking into this, and they've been continually filing patents. And the last patent that was applied for them was filed in 2017, and it was granted at the first of this month. So they're still kind of actively engaging in the patent office with this technology. So essentially, basically the last time they applied for a patent was in 2017. The thing that popped up in my head is the semi-truck and the Roadster were both unveiled in 2017. That was kind of the last we kind of heard, the last patent that kind of came up from there. So you would still need pump and air filters and stuff like that keep bringing it down. That's kind of why it keeps dropping. So there's a lot of things that play into a role into setting up the system. However, one of the things you'd need is a high efficiency particulate filter, basically. So like a HEPA filter to filter out particles so that you don't get a lot of small particles that are going to block get into the oxygen. Wait a second, what does the Model S have? The Model S has a HEPA filter already built into it. And so there's certain things that are just kind of weird. And basically the whole concept behind what Tesla patented is not a full metal air battery. It's a hybrid battery. So you have the problem with metal air is that the same thing that you have with a lot of higher energy density cells is that cycle life. So you do a portion of the battery, like half the battery is metal air, and the other half is non-metal air, and you do most of the cycling on the regular lithium-ion battery that now can last 1,000,000 miles, and then you tap into this extra amount of battery when you need to, and only when you need to. So it extends your total range pretty substantially, but there's all these things that go into it like that. And then kind of because you have it half and half, you don't get the full, like, let's say even if it was 800 that they could commercialize, you would have like to do fractions to get a total pack specific energy, because you actually have to, so it drops down even further. However, you can still get to an above 400 for the whole pack theoretically, just based on like assumptions. You could still get above a 400 watt hour per kilogram on the pack level, because you have a high one and then a lower one. One of the things about that, the issues that I don't know, a little bit about me for those who are watching. I had another.
I was going to wait.
Go ahead.
I was going to wait until we actually start the live stream in about 6 minutes. Like, this is just a bit of pre-chat while we wait for everybody to show up. And then we'll do a proper introduction for everybody and let everybody know how we know each other, and start answering questions and go through a few things that's on my mind and your mind. But I'd also want to thank, I see there's a lot of people typing in the chat here. Tauranga Talk, thanks for becoming a member. And a little bit further into this, we'll start answering some of the questions that you have, hopefully in about, 15 or 20 minutes. But there's so much to go through. This could easily last an hour, 2 hours. We'll see how it goes. We might need to eat. So, yeah, go ahead. What were you going to say?
I ate right before this, so I'm good to go. No, I was basically saying that I was looking into this at the beginning of this year, because I had a YouTube channel. I still have it, but I kind of let it die out a little bit because of school, because I'm attending school right now. And I was putting so much into doing research on, is it even possible for them to do these metal air batteries, that my grades started to slip. So I had to kind of decide, okay, is it the channel or is it these metal air batteries? What do I have to make the priority over? And so I spent a ton of time researching into this. And what I kind of concluded is that it's a long shot, it's unlikely, but it is possible. And that's just the interesting thing. Like, if there was like a wild card prediction that I could make, that where it's like out of nowhere, nobody saw this coming, that would be it. That doesn't mean I honestly can't say I think it's going to happen. Just because there's a lot of limitations. There's very little actual like published research on it, like from universities and stuff. But like I said, they've been working on it in their labs since like 2010. So if they've been working on it to try to commercialize it since 2010, it takes about 10 years to commercialize from like a lab prototype to that. So theoretically they could get it to work, but that doesn't mean they will. And
yeah, it's good to know that they're working on these things. And at this point, you know more about those air batteries than I do, because I haven't looked into them at all. What I kind of do is I look across the broad spectrum of potential technologies. Yeah. I try to find the one that's most likely, then I start digging in. But I like the fact that, and this is where I would have liked to have seen your channel would have gone if you would have stuck with it, is to dig into these things that are long shots that are really fascinating. But there are other more interesting things that I think you're working on, which at some point in the channel we'll have an interview and we'll discuss the things that you're working on. But I don't know if...
Oh, definitely.
Yeah. I don't think now's probably too early to discuss them, I'm assuming.
Most definitely, yeah.
Okay.
But
cool.
still super early in what we're working on. So
Yeah. And in terms of oh, what's that?
oh, just something. Someone said something in the chat. I was laughing.
Okay.
They said Drew TRP said, "Hey, stay calm. I come from Reddit," and I was like, "That's funny."
Yeah, and there's a comment from Battery Bulletin. He says that Metal Air is too far.
I was reading that too.
It won't be commercialized, until 2050. So yeah, but that's essentially what you're saying. It's kind of a really
I don't think that it's going to happen, but it's possible, and that's just why I brought it up, because then if it happens and I say it's possible, then I look really smart. But if it doesn't happen, I don't look that dumb. I'm just kidding.
Yeah, I know what you mean. It's fun to get excited about these things, and I at the beginning of the channel I got a little bit overstimulated and I had to rein myself in. I talked to a researcher and he kind of pulled me back and said, "Oh, there's more likely paths than what you're discussing," and he kind of educated me a little bit on the lab to market process. So I really appreciate that. And I don't know if people noticed, but the quality of my content jumped in about March after that I had the discussion with him. He started teaching me some of the research terms that I didn't know, because as somebody that somebody in the general public, if you read one of these research papers, you do not understand what they're talking about because they're using words that you've never heard before. To the people writing the research papers, it's part of their natural language. There's a common understanding about what's being discussed. But in order to crack that, a lot of the words have different meanings in the battery community than the words that I'd look them up and it would have a different meaning. So, but once you start getting a toehold, once you get a larger and larger grasp of all this glossary of words, then it becomes easier and easier. So each video I do, it gets a little bit easier. Yeah. It's 12:59 here. What time is it there? Getting close to 6?
It's about to be 59, so about to be 6.
All right. It's 1 p.m. We'll go ahead and kick off now. Thanks, everybody who's in the live stream. How many people do we have watching at the moment? 847. So, Ryan, don't get nervous. There's about an auditorium of 1,000 people looking at you right now. Probably the best place to start is to introduce Ryan. I'm sure everybody here knows me, knows a little bit about me. I've done about a dozen interviews in the last 9 months, but we can answer questions about me later in the chat if people would like to do that. I met Ryan, I think it was early February. Both of us started releasing videos at about the same time. Ryan did a great video on dry battery electrode. He where did you get that information from? It was a battery research book that explained exactly what DB was, or was it a patent that you went through?
There was several patents that Maxwell filed, and I was able to. I was like, why haven't I Googled the patents? So I just Googled it, and I was like, oh, this explains how the technology works step by step. Why didn't I do that before? So I just kind of Googled it and was like researching it and looking up, kind of cross-referencing things and trying to understand it. The original sheet I had was like, I printed it out so I can read it and mark it up and try to figure out exactly what everything means. And so, and it was like, it was several pages. So, there was like another, there was a couple other papers and stuff. And basically the reason why I looked it up is because there was a lot of talk about it, but there wasn't a lot of talk on actually how it works on like a really small level. And that's what I was looking for. And then I was able to find it. And I was like, well, I need to kind of release this because nobody's talking about this. And so that was kind of the last video I made because I got distracted after that with school. So, yeah.
And I really enjoyed that video, and it felt like we were pulling the same direction. Both of us were looking out into the battery sphere in terms of the public, and it didn't seem like anybody was providing that next level of detail to explain, is this feasible? Why is it feasible? How do these technologies work? So both of us had pretty much the same idea within a week or two of each other. I found his
Yeah.
channel because maybe you commented on. I'm not sure if you commented on my channel or somebody else's channel, but that's how we connected through the comments section of one of these videos,
Yeah.
and we started talking, hit it off, and here we are. We keep in contact pretty much on a weekly basis since the beginning of the year.
Yeah. Yep.
And people are probably also wondering about what your background is, so I'll let you give yourself a little bit of an introduction.
Yeah. So right now I'm going to Cal Poly Pomona, and I'm studying mechanical engineering, and this is my last year over there. So for me, um, I started really looking into, okay, what is the future technology? What industries do I want to get into that the future that will be the future? Like, what are the industries of the future? And so I realized pretty quickly on that, like, batteries is one of those industries that is going to be the future industry. That's going to be the crux of transportation, of energy store, or like energy storage, all these things. So I started looking into that, and following Tesla, since I had a funny story actually. I had a professor in one of my classes who was taught. He was an electrical engineer who used to be the CEO of an oil company, and was now teaching electrical engineering to mechanical engineers because he retired. And so what he was doing, what he was like, the way his style was a lot more business like, in the sense of, like, he didn't assign homework. He basically told everybody, hey, research this. We're just going to have a meeting and we're going to talk about it. Almost like a business meeting style. And he would basically call out random people in the audience and say, hey, you answer this question about this. And so the way that he thought was going to be the best way to teach mechanical engineers about electrical engineering was to look at the components inside of an electric car. And the most prolific electric car is Tesla's. So back then, that was around 2017. That was like right before they were about to release the Model 3. And so there was still a lot of information coming out about that. And so the main point of it was all about the Model S and describing, here's how the batteries work, like high level on how battery packs work, not necessarily how the battery works itself. And because the way the class was set up, I just so happened to start doing research into kind of batteries and, like, okay, well, here's how the chemistry works and here's how this works. And because it kind of encouraged, hey, if you learn something else and it's interesting, talk about it to the rest of the class, because you're going to basically be teaching the rest of the class. I ended up talking about it to the rest of the class. So a lot of my base level understanding of how basically Tesla works came from that class, because I had barely heard of Tesla before that class. And I came out of it being like, oh, this is cool. So I started following them. And then I got a lot more interested in battery technology. And then when I heard about the Maxwell acquisition, that's kind of when me personally first started investing into them. It was like literally the day of the Maxwell acquisition, I pulled up one of their, like, white papers and was like, oh, wow, okay, yeah, this is definitely a good thing to invest in. And so let's see, where was I going with this? But yeah. So then I started doing research into it a little bit more and following it closer. And then after starting to follow Elon Musk from that, I basically, I realized, like, I heard him basically say, oh yeah, I learned rocket science by picking up books. You know what I mean? Like that's how I kind of became, like, there was that interview with 60 Minutes where he basically said, I picked up a book and that's how I learned about rocket science, so that I can actually be like the chief engineer of SpaceX.
Yep.
So I heard that and I was like, wait a second. So if I'm interested in this, why am I waiting to take a class on it? If I'm interested in something, I should just go out there and I should pick up a book, because there's thousands of them, watch some YouTube videos that are out there. And there really wasn't that many on, like, detailed battery stuff. And so it became, I picked up the Linden's Handbook of Batteries and I started reading that. And then I realized, oh my gosh, there's so much that's not out there. That's like common knowledge in the battery community, but that's just not common knowledge on the internet. So I was like, let me make a YouTube channel to try to start this. And so that's how that started. And then I made a video, and then that's how we connected. So
yeah. So
and then the reason why I'm on the channel right now is because I got a ticket to Battery Day, and so that's the pivot that I'm gonna make on why I'm here.
Yeah. Yeah, Ryan got a golden ticket, so he's going to be our correspondent for Battery Day. And let's see here. The best place to go from here is just there's a few things that I wanted to review before we get into questions. Things that I don't feel like I provided enough explanation on when I did my last Battery Day video. One of those is I don't feel like I provided enough support for why a 4x might actually be possible. A 4 times production speed might actually be possible with Maxwell dry battery electrode. When I look through Maxwell's old documentation, which I'll bring it up now, I'll just put it over my face. A second. I'm not sure if there's sort of a standard definition of what a pilot production line is. However, they were targeting, with a pilot production line, 250 meters at greater than 25 meters a minute. So 25 meters a minute is the key figure there. This is from Maxwell and A123 Systems, their own documentation, and it was from back in 2012. A typical pilot line, at least from the research papers I read, was about 5 meters a minute. So it looks like their pilot production line was about 5 times as fast as a typical pilot production line. Now, I don't know if different manufacturers and researchers have a different definition of what a pilot line is, but when I see this in 2012 at pilot scale, they're going 25 meters a minute, which is 5 times faster than a wet slurry process. It seemed like a 4x speed increase was well within the bounds of what I'm seeing there. But I pulled that back even further, and I said, hey, even a 2x would be amazing.
Oh yeah.
A typical battery production line is about 80 meters per minute. A full-scale commercial line is 80 meters a minute, which is 3 times that speed. 80 meters a minute, I think, is about walking speed. Does that sound about right to you? I think it's about 3 miles an hour. So this would bring that walking speed. It would bring that walking speed up to a running speed. The reason why they can accelerate it that quickly is because part of the reason is you don't need these hundreds of meters of drying line to dry it.
Yep.
And I think coating with a solid material might also be more stable and more easy than coating with like a wet slurry process.
Yeah.
There's other ways that can accelerate that, which I didn't even get into in my Battery Day series. And you probably know where I'm going with this with flame spraying. So bring me back around to that if I forget.
Okay.
Another reason why I thought the 2 to 4x line speed increase might be possible is in Maxwell's documentation. They said it was about a 10 to 20% cost decrease with a dry battery electrode process, which lines right up with George Bauer's estimate of a 10 to 20% cost decrease with a 4 times speed increase with the Maxwell technology. So there's a few things that point to that 2 to 4x line speed increase. My original Battery Day series, I said, hey, maybe 1.2 to 1.5. The reason why I went ahead and I gained a little bit more confidence with that 2 to 4x line speed increase was the fact that Elon said, hey, maybe we'll see terafactories someday. In order to do a terafactory with similar size factories that they're using now, you would need a 4 times speed increase. Now, back to the flame spraying. Do you want to explain what flame spraying is? Because typically the Maxwell process is you run the dry material through an extruder, and it kind of mushes it up like bubble gum, and it starts getting strands and stringy, and then it's run through an extruder.
It's I think the process they described it was fibrillization.
Yeah, fibrillization.
It makes little fibrils. Yeah.
But what both of us also found is there's another way to coat electrodes, which may be much faster. I don't think it's likely for Battery Day, but it does open the door for potential going well beyond 4x would be electrostatic and flame spraying that material onto the electrode foils. I'll explain electrostatic deposition, and then you can explain the flame spraying. Electrostatic deposition is the same way that they coat paint on cars. They apply some current to the car, and they apply some current to the spray that's coming out, and the spray attracts to the material because they have different charges, and it creates an even coating on it. Yeah, and that's pretty much all there is to it. You just run it through a room that has all these charged particles and the charged material, whoop, and it sticks right to it. This is all moonshot stuff, but things that were going through my mind and things that were going through your mind that weren't really covered in the Battery Day series because I didn't think they were likely. So do you want to cover what flame spraying is?
Well, so from what I understand, it's basically like shooting the powder through and heating it and shocking it so that it sticks to stuff, right? I'm not too familiar with it, to be honest.
Okay. Yeah, my understanding is when you were a kid, did you ever, we got these flavor ice wrappers when we were kids, and we used to light them on fire, and then liquid plastic would drip. To me, I kind of envision it like that, where you're running, instead of just burning a flavor ice wrapper and having it drip the molten plastic, you're just shooting a spray of plastic particles through a flame, and then they turn to a liquid state, and then they splatter, and then they hit the electrode foil. That makes a really cool sound, by the way. If you ever get a chance, light a flavor ice wrapper, and it makes a really cool sound when the plastic drips off.
Interesting.
So that was probably the primary thing I wanted to cover off that wasn't covered. There was also the electrode thickness. In the original Battery Day series, I said that they could increase the cell energy density by increasing the thickness of the cathode and anode. For people who didn't watch that video series, the reason why increasing the thickness of the cathode and anode would make for a higher energy density cell is because it reduces the ratio of active material to inactive material. Generally, I think an electrode foil is about 10 microns thick, and then, I don't know, for anode and cathode, it's something like 40 to 80 microns thick. So the electrode foil is actually pretty thick in comparison to the active material. Yeah. If you can increase that ratio, you have more active material, you get higher energy density. So I think now is probably good.
I think.
Go ahead.
And I think you were saying that the reason why they generally don't increase the thickness is because of temperature concerns, right?
Yes, that's a really good point.
Because if you have the end cooling, and then you have the tabless electrode, and then you also have the DBE process, all three of those play together into reducing the resistance of the system.
Yeah, so if you have thanks for drawing that in, because it's this is an example. Assuming this is your cathode or your anode, and these are to the entry and exit points for your ions. And also on the other side, it would be the electrons. The thicker that is, the harder it is to get all those cars in and out of. Assume this is like a parking lot. Assume that the cathode and anode are a parking lot. The thicker this area is in here, the larger the parking lot, the more bottlenecks you get on the entry and exit points of that parking lot. And the more traffic jams there are at those points, the more friction there is, the more heat that's generated. And so quickly your cell's going to overheat if you make that cathode and anode too thick. And that it also causes problems when you try to roll that material, because it's harder to roll a thicker material without you getting creases and kinks in it. And I'll bring up the triangle, which you're mentioning. I'm glad I have you on here, because I would have completely forgotten to bring this stuff up. Okay, yeah. And this is what I was talking about with the limits on Tesla's engineering. You have the charge and discharge rate. The faster you charge and discharge a battery, the more heat that's generated. So that causes a problem with heat and the thermal load. The cathode thickness, you make the cathode thicker, you're going to generate more heat. If you make the cell thicker, you're going to have more heat. And the day that the tabless electrode patent came out, I made a video because I was super excited about this and I could immediately see the benefits of it. And what this allows us to do, it actually allows us to shrink the size of this triangle or expand, depending on how you think about this. But it allows you to solve all the problems at once. The tabless electrode helps out a little bit with that, and then the plate cooling, a better cooling system would also help out with that. So they might be able to increase cell volume, which makes manufacturing easier, along with making a thicker cathode, which increases energy density, and at the same time get a higher charge and discharge rate. It's a trifecta. If they're able to achieve all three of those things at battery day, they've solved some serious engineering challenges, because it's basically a first principles problem. In order to solve a first principles problem, you have to have some really creative engineering. All right. Now, is there anything else you want to cover off, or should we start looking into the questions and then start gathering questions for battery day?
Yeah, I mean, I did notice that we had two super chats. You want to go over those?
Yeah, sure.
Real quick.
I'm just going to scroll up through the comments. Sweet. All right, first, Nate H. Thanks for the super chat, Nate. What do you think the probability that Tesla announces a battery recycling partnership with J.B. Straubel and Redwood? I don't know the odds, but it sure seems suspicious and extremely convenient that Redwood Materials, their processing facility is just south of the Sparks, Nevada Gigafactory. What was going through my mind is you have these semi-trucks going back and forth already between Fremont and Gigafactory to deliver powertrains, battery packs, etc. Why not, when they're on their way to Giga Nevada, pick up battery scrap material and go down to Redwood Materials and drop it off. And then on the way back, pick up all your spare parts and things like that. It would just be, it's right in the same logistics arc. And then what they could also do with the battery scrap that's coming from Fremont, pick the battery scrap up at Fremont, pick the battery scrap up from Giga Nevada, go down to Redwood Materials, drop it off, and then on the way back, bring your goods. It's like Railroad Tycoon. I don't know if you ever played that.
Yeah, I think I think part of the reason why he split off and kind of did this separately is so that he can actually work with all the car brands. And that seems a little bit not with what most people are thinking with it. I think part of the reason why is I think he realized that, okay, if it's just Tesla working on this, we're not going to get enough actual cell materials. So I think by splitting off and working on his own with that. So I don't know if I don't think they'll enter like an exclusive agreement, but I think that there'll be definitely a certain aspect to it that at least temporarily they're going to be supplying a lot of stuff. I think what he's really trying to do is start up basically a recycling mine where you could just ship the materials and turn them into like almost like new raw material, even though they're recycled, and then supply those to whoever wants to buy them. And I just think that Tesla's going to be the first one that's going to want to buy them. So I think that's why they set it up there. I don't know if they're going to enter into an exclusive agreement there. I think also part of the reason why he like left to go do that is because in like kind of the midway towards the beginning midway of 2019, I think they were basically like, okay, we need to be as lean as possible. And I think his program of recycling might have gotten like risk of being cut while they were trying to go lean. You know what I mean? Where it's like, okay, well, we're going to delay this maybe 4 or 5 years. And he was like, I can't do that. So he went and did it separately. Personally, I think that's kind of what's going on, but I totally could be wrong there. Obviously, I mean, I'm not hearing anything from anyone. But there definitely is a possibility, I think, that they'll announce a partnership. I definitely am not, do not think we should rule it out.
I think a lot of it depends on, and this comes down to the point where Tesla is now developing multiple supply chains. For Giga Nevada, my understanding is they already have a recycling facility, and I think it might be out of Canada or something like that. Whereas
Yeah.
Redwood would be, it might be a completely separate contract. I don't know how long
Yeah.
Tesla is locked into their Giga Nevada contract with that other battery materials recycler.
Mm-hmm.
So you make really good points. And another thing that I don't like about Redwood is they're using a thermal process, is my understanding. A thermal process is you don't get all the materials out of the battery. It's basically you're melting down the batteries. I don't know what the safety for the environment is like for that, but hopefully they're also working on a more advanced chemical process that you just dissolve the materials into like an acid leaching solution, and then you pull the materials out that you need, and you get pretty much all the materials back out of the battery that you originally put in.
Yeah.
And I wonder if Yvonne's also watching this, because Yvonne is at work. Yvonne from the EV Stock channel is also a mutual friend of ours, and unfortunately he wasn't able to make it today, but he might be in the comments somewhere because he's been doing a lot of deep dives into recycling.
Yeah.
So to Nate's question, which is a really good question.
Yeah, it really is.
I think it's 50-50. It really depends on what contracts
are in
place.
Yeah.
And if the battery lines for the new line are going to use a completely different supply line, which I think they will.
Yeah.
Go down to the next one. Wouldn't the tabless electrode also allow for faster supercharging? Okay, let's get into charging. This is always a very difficult question to answer, and I can never actually give a good answer on it because there is no real answer from the perspective of an outside analyst. It does allow for faster charging, but as with the triangle that I showed earlier, it also has the potential to improve other areas. And they can design cells so you can either get better charging or you can get better energy density. It's always a trade-off decision. So it comes down to what Tesla's decision-making process is. The speed that you get a supercharger is a combination of multiple things. One, it's the speed, the amount of power or energy, electricity that supercharger can put out. It comes down to the pack architecture, what the battery management system is like and the cooling system is like. Then you get down into the cell level where what's the thickness of the cathode and anode, what sort of ratios are in place there. Because if you create a higher ratio of electrode foil to active material, then you can get those electrons in and out more quickly, but then you lose energy density. My view is that, they should continue to apply some of their thinking process and engineering to improving the charge and discharge rate, but their time and energy is much better spent on, first of all, cost and then energy density. Because if you focus on power density, you aren't getting any positive side effects from that. If you focus on cost and energy density, you do get benefits to charging speed because you can put a bigger battery in the vehicle. A bigger battery, because it holds more energy, it can sustain a higher rate of current for longer. Yeah. So it's like, say the first 50% that you're charging a battery up, that's the quickest, and then it drops off from there. Well, if you have a bigger battery, that 50% lasts longer. You get more energy stored.
And if anything, I think because a lot of the things that they're introducing are going to be pretty big reductions in resistance, which means that when you reduce resistance, you reduce the amount of heat generated by charging, discharging. So if that is the case, then we have then there's a very big possibility that they could use that to charge a little faster and leverage the not as much heat being generated to charge probably more consistently. But it like he said, it's all about what their game plan is of, okay, how are we actually going to, what is our end goal? Because if you look at, just in general terms of in general terms of like the statistics, it's like 80%, greater than 80% of the people that charge their electric cars charge it at home overnight. So, I mean, that's not necessarily, oh no, we shouldn't focus on improving the charging speed, because most of the people that you talk to who are not interested in electric vehicles are like, well, how long is it going to take to charge if I got to go recharge it? Right? That's a big mental barrier that a lot of people have. So I think it is important to be reducing it, but I don't think it's going to be their main thing. I think there is going to be an increase, but I don't think it's going to be as big as an increase as a lot of people are thinking.
Oh, and Elon did show up in the chat. He said he'll be for the next live
he did,
chat.
Yo! Nice.
I know he's feeling left out, sending the love. He's at work. So let's see. We also have David Chan commenting, which David Chan is also a friend of the channel. He has his own YouTube channel. Hey, David.
Nice. What's up, David?
And what else? Have you talked to David Chan yet? If not, we'll have to get you connected.
I have not.
Yeah. So he runs more of a finance and investing channel. Voltage. This is something I really haven't had a chance to look into yet, but the more I look into it, it's the same as the battery charging speed issue. It's like, well, if you increase the voltage, you actually also create other problems. For instance, higher voltage components create higher levels of degradation within the insulation materials in the battery. Not the battery, but your electronics components. So if you have something that you want to last for 1 million, 2 million miles, then you may not want to go with a higher voltage. And if you're not focused on charging speed anyways, total charge rate is dependent on amps times volts. So you can either get that higher charge rate by increasing the amps or increasing the volts. And there's, positives and negatives to picking one over the other. And to me, it seems like if Tesla's usually pretty far-sighted. So I would think if they would have gone with a high voltage system, they would have done it a long time ago. And Bjorn Nyland, who also runs a YouTube channel, has shown that the manufacturers who actually have provided higher voltage, higher charge rates, they're actually offering their customers the option to charge at a lower rate now, because it may be causing the battery to degrade more quickly than it should.
Degrade faster, yeah. So because you have a lot of those, because a battery pack is a lot more than just a combination of cells, and I think a lot of people don't realize that when they're talking about things. They just assume, okay, well, a battery pack is just a bunch of cells stick together. Well, it's a lot more than that. There's a lot of electrical components that'll go into it to actually, especially with lithium ion, because you have to be able to stabilize it. You have to maintain all the voltage rates and everything to make sure everything's on the right track.
So that's voltage. Let's see. Are there any women in the chat? Somebody asked. Probably not. My viewership is 99.7% male. So is there any question that you folks have? I'm just starting to read up through the comments now. Oh, wait, Sue Valentine. We do have a woman in the chat. That's really good. I would like to see more women watching the channel, because apparently the material just doesn't appeal. Okay. And Battery Bulletin made a comment about LFP allows for fast charging, low voltage, and low cost, reasonable range.
I was just looking at that, yeah.
I think that's a really good point. My view is that Tesla's entire base range of vehicles should move to lithium iron phosphate if possible, because there's no reason not to. For if you have a vehicle with around 250 miles of range or less, you're going to be saving about $20 per kilogram or $20 per watt hour. I forget which. My brain's cooked. But anyways, it's going to save you thousands of dollars at the pack level. I do think that they're going to stick with their current supply lines for what they have in the U.S., but I think as they open new factories in other countries, they're going to use the chemistry that works best. But if they have an established supply line, I wouldn't think you need to disrupt it if it's already profitable. But I would like to see that in the future.
Oh, yeah. which I think that brings up, where do you think the first cells are going to go for their Roadrunner line? And when do you think the Roadrunner line is going to actually be running, up and running? Do you think it's already running or what?
I also need to give a shout out. There's another girl in the chat, Kate. Um, now, in terms of what I expect, it really depends on the amount that Fremont facility is able to put out. If Maxwell had a pilot line in 2012, and they had an R&D facility at Cato Road, and now they're building a second level to that, I would love to think that they're past the really small scale pilot stage and they're moving into like a full scale commercial production line. If they are, then, and if we see that extra cell capacity, let's say like 2 to 4x speed increase, then I would think we would be getting the entire S and X range with plaid. Well, not plaid, the entire S and X range with the new type of battery pack. And then the plaid would have some sort of extra capacity or extra fast discharge rate. I don't know. They might still want to have that delineation, but it makes more sense to put all the vehicles on the same pack. It'd be kind of weird to have two completely different battery packs running off the same line. It makes sense when you have like a 60 and a 75 kilowatt hour pack, but when you're running two completely different technologies, I don't know if that's feasible. So maybe do the entire S range and the entire X range, but I would think you'd need to do S and the X at the same time just to keep things simple and to remove the Osborne effect. And then after that, Cybertruck.
Yep. And I think there was one person, there's a couple people talking about it in the chat, and they mentioned that basically the one person said that the factory, the Roadrunner is already running, and another person did point out that there is the construction at that facility isn't actually complete. Like, I was looking this up just not too long, like right before we went live, and as of like the end of August, there was still a lot of construction going on at that facility. And that's why I bring it up. Is it already running, or is it still going to be a little bit of time before it is running? How is that going to impact? Because I think that is going to have a big impact just on terms of battery day, what they're going to announce. Because I think they want to avoid the Osborne effect. And if they come out on battery day and it's going to take 6 more months to finish the facility that produced the batteries, and they come out and announce a car, that could impact their sale. You know what I mean? But that's just what I'm curious about. I'm curious to see when I get to go. I'm really curious to see if they're going to show off that, okay, here's the line that we're building. Mostly just because I want to wear a hard hat.
But you're gonna ruin that perfectly coiffed hair. It's interesting to note that R&D line that they have, they refer to it as Terra, as in Terra Factory. So I do think it's maybe the R&D line is version 1 and Roadrunner is the version 2 that actually gets them across the line, because something would have had to have made the cells that we saw in the plaid Model S that we saw at the Nürburgring last year. So that there's already some capacity there. But how much, we don't know.
I'm almost curious because the first line that they already built and it is already running is Terra, right? And the one that they're currently building is Roadrunner. So I'm curious if the Terra is going to be more the mass market version of the battery cells they're going to be making, and Roadrunner is going to be the high performance one, where they're able to take a little bit more risks when it comes to like have it a little bit more expensive to get a little bit higher performance out of it, just so they could build stuff like the Roadster, the top line Cybertruck, the plaid models. That's kind of what I'm curious about. If I don't know if you're on the same, because
I
one
know
of the
what you're
things that
saying.
Elon did say is that he's going to put the that he's the first Tesla special batteries are going, like produced batteries are going to be in Berlin, and Berlin's most likely going to go online before Austin. So it's like, what batteries are they going to go online with there? You know what I mean? So it could be that their Terra ones are going to be the ones that they're going to be active, like going on first, and maybe it isn't quite as high energy density, and they just go purely for cost and scalability.
I see what you're saying, because, like, for instance, if you did a single crystal cathode, you did all the bells and whistles, you might have a more expensive but a more higher energy density cells, and you use those for a specific use case like plaid, and then you use something that's still better than the Panasonic cells, but a little bit cheaper, and use that for Cybertruck, something like that. Is that what you're saying?
Yeah, that's kind of what I'm saying. And then you use they start building out the higher cost ones first to amortize the costs down. So they could try to, so that not all the costs of the new equipment and all the new lines are all at the beginning. You prove out the technology in the lower volume applications.
Yeah, that's it fits with Tesla's pattern of behavior, so I wouldn't put it out of the question. In terms of Berlin, I don't know. I think it's gonna. I don't think they're going to be the first to get those battery cell lines. Elon's comment last week was very cryptic about using an entirely new core technology. Are they talking about voltage? Are they talking about the pack cooling? Are they talking about the cells? Well, what does he mean by core technology? And when do they plan?
Because remember, battery isn't just about cells. Battery is about the whole battery pack, right?
Yeah.
So there's a lot more probably to battery day than we're, because everybody's always thinking about batteries, they think of cells. So it's possible that they do introduce a new, maybe a higher voltage with a longer life battery pack. You know what I mean? Like with where they have they higher voltage components that can take higher voltages than their normal components to introduce. You know what I mean? Like where they'd have to go and change some components out to reach higher voltages in order to get it to actually last long enough, like you were saying earlier. So they may have to redesign the whole battery around a higher voltage if they wanted to introduce a higher voltage.
Yeah, that would be a completely replacement of the core technology. And jumping back to Nate H had a question: do I have a Discord channel? If not, please. What I'm running into is I feel like I'm getting stretched too thin across too many different media platforms, because I have my Twitter, I have my Reddit, and that stretches me thin at the moment because I try to interact with people as much as possible on each of those platforms and YouTube. So at the moment, there's no plans for a Discord chat. The original plan for the Reddit chat was to get people talking to each other about batteries. But it's not like aerospace or something like that where there's a lot of knowledge out there. There's not a lot of people who know a lot about batteries. So what ends up turning into, and which I don't mind, but I just don't have enough time for, is answering a lot of people's questions about batteries. And I'm already answering all the questions I possibly can on Reddit, YouTube, and Twitter. And if I had another one, it might be the straw that broke the camel's back. So that's the long-winded answer on Discord. So we'll go down and check if there's any more questions. Okay, there's a lot of questions as I'm going up through this. I don't know where to start.
That's what I was saying. I was looking at it, I was like, geez, there's a lot of questions here.
Which is
wait,
thanks, Nate H. That does provide a hell of a lot of motivation.
I was about
to say. Excellent. And a lot of good questions, Nate. That spurred a lot of good discussion. There's so many things on my mind that I often need people to prompt me about these things, because there's no way for me to remember all the things that I want to talk about. Often I'll get off one of these chats and they'll be like, oh God, there was about 20 other things that I wanted to talk about that That completely slipped my mind.
So I've seen a couple comments on asking about the 12-volt battery system, because I did think he did mention that the 12-volt battery system, or Elon did mention that the 12-volt battery system in a tweet recently, that it has some issues.
Mhm.
And I think because if you look at the way that like a Tesla is designed, the 12-volt battery system is basically a buffer of all of its subcomponents, like all the screens, all the buttons, and all that stuff runs through the 12-volt battery system. And there has to be like a step down from the main battery pack to the 12-volt system. But because it's running all the screens and all the electronics inside the car, the 12-volt system actually gets it's not actually a lithium-ion battery. It's from my understanding, it's like a lead acid battery, like a normal car battery. And so it actually ends up getting cycled way more than the rest of the battery pack. And because of that, it's one of the earliest things to fail in Teslas, is like you tires and then just that main battery pack. And so what they were talking about I think Elon was talking about in the past that he would want to replace the battery pack, the 12-volt battery pack, with somehow connect it directly to the normal battery pack. What are your thoughts on? Do you think there's a way that they could work that out, or what would they replace the 12-voltage battery pack with? Although Battery Bulletin just commented that he thinks they're going to replace it with a supercap, because Maxwell did have those kind of things in their product listings.
Oh, duh! That's a beautiful idea. I haven't even thought about that yet. I was against the idea of a hybrid cell to pack with supercapacitors and a battery, but boom, I just had a brain explosion. A supercapacitor instead of that 12-volt battery. That's perfect. That would be beautiful, because then you would never have that 12-volt battery go dead. You'd want the supercapacitor that the whole system runs through to have a longer cycle life than the rest of the battery pack. Supercapacitors to use for more storage than that, I think, would be too expensive. So I've been thinking the supercapacitor would be good for things like the air suspension, things that are like running minor systems that are constantly cycling. And yeah, running it through I don't know enough about electrical engineering, but that's a brilliant idea. And while you were talking, I was going through and I was noting all the other comments that people made. Before we get to those, to me that does seem like the core technology of the car, and maybe that's what Elon's referring to. You strip out that 12-volt battery, that old lead acid, toxic, prone to failure lead acid battery, and replace it with like a supercap or wired in directly to the actual battery pack. That makes more sense than me. The best part is no part. I prefer it to be no supercapacitor, but a supercapacitor seems like it would be better than lead acid. There's a couple questions on Roadrunner. Hold on a second, I'm going to clear my throat. What's the meaning of Roadrunner? To me, the meaning of Roadrunner is the fact that these cells are just going to be meep. They're just going to be blazing fast. And everything else, all the other battery lines, you could consider those Wile E. Coyote. Will Roadrunner be the million-mile battery? First, we need to take a look at what the million-mile battery actually is. There's an Easter egg in my last video that only one person picked up on. I said, is Jeff Dahn's battery actually a 2.5 million-mile battery? The criteria that Tesla gave Jeff Dahn was to have a battery. I'm just going to go make this full screen so people can see it better. The criteria that Tesla gave Jeff Dahn for the million-mile battery was a full charge and discharge cycle, 0 to 100% at room temperature at a 1C discharge rate. So 1C discharge rate would be charge and discharge the battery within an hour. So basically charge and discharge the battery within an hour at 100%, and it should last 4,000 cycles. Well, take a look at this red line. At 4,800 cycles, it's still above 90%. End of life is considered 80% for a battery. If you project this line out, you're looking at 10,000 cycles. If you have a 250-mile battery pack, you're looking at 2.5 million 2.5 million miles. If you had a 500 mile battery pack, that would be 500 mile battery pack would be 5 million miles. And this has other implications. You may be able to reduce the amount of costly materials in that battery and still get a long cycle life battery. For instance, you might be able to replace the synthetic anode with a natural anode. Reduce the cost. And for a vehicle, that makes sense because you want these batteries to be as cheap as possible. And there's no sense in having a battery that lasts 5 million miles because the car is going to die well before that battery dies. However, they could use these more expensive materials like synthetic anode in their power storage solutions, which need 10, 20, 30,000 cycles.
Yeah. Well, and then I think something to bring up real quick. One of the interesting things that you do see if you look on Tesla's job postings, half of the job postings describe their batteries as Tesla energy batteries. So that could mean one of two things. Either they're putting their battery manufacturing division underneath their energy division, which actually does have an implication in terms of, like, Elon said that their energy division is going to be bigger than their automotive division, right? So if they put that under that division, that actually plays into that a lot. Or that means a lot of they have a separate battery system for basically Tesla and like Tesla energy batteries and designed them specifically. Both of those are possibilities. It's unclear to me just from reading the job postings.
Yeah, you're very thorough with the job listings and the patents. I should set some alerts for those. This kind of brings us to a nexus, which is the Tesla Semi, which I was 50-50 about whether it would use a dry battery technology or Panasonic's wet slurry technology. Obviously, the Roadrunner cells would allow the Semi to have a longer range, but I wouldn't want to base the ramp of a vehicle that has enormous cell needs on a developing technology. You'd want to put that in your cutting edge vehicles. The Tesla Semi, Elon also said in the earnings call directly after the Semi release, was that the technology they had at that point was good enough to provide the specs that they stated on the Tesla Semi unveiling. And since then, they've made a huge amount of improvements to both their efficiency and their batteries. Not a huge improvement on their batteries, but there has been some improvement on the batteries, just like a few percent is my understanding, and their efficiency has gotten better. So they should be able to do better than the specs they gave at the Tesla Semi unveiling with their standard, Model 3 motors and batteries that are coming out of Giga Nevada. That's my thoughts, at least. I don't know if you had any view on that. I would love to see Roadrunner cells in it. It would bode well for Roadrunner, but I think that would be too many vehicles at once.
Well, and then I think the big thing is going to be, how do you get volume for... That one is like a pure volume play. How do you get as much volume of cells as possible for the semi-truck? So I think personally, I think that the reason why the semi-truck kept getting delayed was because of batteries. I think the original, because I think if you look up the one of the early Galley videos, the videos that Galley put out, mentioned that they were already in like 2017. Tesla and Maxwell were already in like a relationship of where Tesla told them to like start testing the cells in like a small pilot line. I think it was in Arizona or something like that. Just to prove that they could actually do it in like a manufacturing scale and it's not just like a one-off cell. And I think once they actually got the results from that, that's when they bought them out. That's when they actually went in there and were like, okay, no, we're buying you out. That's when they started like proposing that. So I think the original plan was to buy the cells from them, and that was the original timeline. And then when they realized how good they were, I think they actually went in and said, okay, no, we're going to buy you out. And when you buy out a company, it takes a lot longer to actually restructure them into your business in order to actually reach that level that they need to. So I think for sure they're going to be using the new technology into it. The question is because, like I said, I think the Terra lines and the Roadrunner lines are different. Personally, I think the Roadrunner that's just my imagination of what it's going to be. I could totally be wrong there, but I think Terra is specifically for hitting those terawatt numbers, and Roadrunner is going to be for the really beating gas cars. So I think Terra is going to be the ones that they're going to hit that scale for the semi, and I think that's why they had to keep pushing it back. But I think the reason why they kept delaying the Roadster is because they realized that the Roadster's technology, they were like, okay, well, we could come out with the Roadster and then like the next year or the next 2-3 years after that completely update it and have to redesign the whole thing, or we could just wait a little bit and come out with one that just absolutely annihilates any gas car out there. So I think with both cases, they decided to wait on it because it wasn't necessarily that they didn't have the supply, which I think they did need the supply, but I think it was also that they wanted to incorporate newer technology.
Well, there's two options there. You could take a tiered approach or a consolidate approach. So I don't have any further insights on that one. There was, getting back to the list of questions that people had here, is the Roadrunner battery a million-mile battery? My assumption is yes. A million-mile battery is actually a really loose definition. You could have a million-mile battery that's 2,500 cycles with a 5,000-mile battery, or a million-mile battery that's a larger pack with less cycles. I think I got my math wrong there, but basically you get what I'm saying. It depends on the size of the pack and the number of cycles is what it comes down to. I think I buggered that up, but so yeah, I would assume it is.
We'll really know if they warranty it to 1 million miles, if they warranty the battery pack to 1 million miles. I think that's something that I would like to see them do. You know what I mean? But I don't know about that.
It's something I had about a half a page written up in the last Battery Day video covering warranty, but it's too slippery.
Mm-hmm. So, yeah, there's a lot of legal implications there, so that does make sense.
Yeah, so I decided to leave that one alone. Though to me, the whole reason why you put a warranty on a product is because there's suspicion that product is going to break down. It's like admitting
that's true. Yeah,
it's like admitting that after 5 years that your product is just going to be a wreck. So, yeah, I think it would provide some confidence, but I think if Tesla builds enough confidence with the market, I don't know if they necessarily need to provide a huge warranty, because it'll be obvious that these vehicles are lasting 2, 3, 4 times as long as an internal combustion vehicle. So I was 6 1, half dozen the other on it. Question about Elon's comment about mind-blowing. Personally, I didn't put a lot of weight on Elon's comment about Battery Day being mind-blowing. The reason for that is Elon, he'll often deliver on something that's impossible, and he'll do it without any superlatives, without saying it's mind-blowing, amazing, things like that. And then there's other times where he'll use superlatives, and then we'll get something that people don't necessarily consider mind-blowing. Like, for instance, before the V3 supercharger came out, he was like, somebody asked him about the charge rate of another charging system, and he said, "What is that, a child's toy?" And he came out with something that was lower than that. So I don't know what he meant by mind-blowing. All I know is what I know is mind-blowing. And that's everything that I've researched, from million-mile battery to faster production speeds to higher power density or higher energy densities. So I'm ripping through these because there's a whole lot of them.
Oh, I know. I see a lot of comments on V2G or V2E, or whatever they're using
V2G.
Now. There was, I don't know if you have gotten an opportunity to respond to this, but I think there was a video put out by, I think, Warren, I forgot how to pronounce his name, but is it what,
Redlick.
Reddick or Redlick or Redlick?
Yeah.
On saying that like V to G is dead. What are your thoughts on that? A little bit of spiciness here, but
I released a video on V to G, then I pulled it down because I didn't. What I like when I do my videos is to reduce the number of questions that are floating around. What I did is I just threw out some numbers that I thought made sense, and I thought V to G was feasible based on those numbers. And I got a lot of comments. I think people expected something more in depth from me, which I'm working on that. I'm in contact with somebody who's now a patron of the channel, and he actually installs Tesla grid storage systems. So I want to pick his brain and see what he thinks about it. Because there's a lot of different facets to it. My view after I did that video was it seems perfectly feasible, but it really is an individual use case thing. If you're on Australia, for instance, it's a no-brainer. If you're in a place where there's a huge difference between the swing rates, or you have a grid that's decrepit and you're having outages and things like that, V to G seems like a
California.
Yeah. Even if it's
That's
just
where I'm at.
yeah. Even if it's just for your own personal use case, V to G makes perfect sense. Because in my mind, there's two versions of connecting your vehicle to the house. There's the dumb version where you just power your house, and there's the more advanced version where you become part of a larger cohort of people bidding on power against the power companies. Definitely for the home setup where you just use it individually, or as a battery backup, like after a tornado or something where you need like the sump pumps in your basement to suck out all the water from the flooding.
Yeah.
But to me, it makes sense the V to G with aggregated, something you can make money off of as well. It wouldn't be a lot of money in most places, but as long as these batteries are going to last, they're going to outlast the car anyway. So you may as well put the car to work doing something and get some money back out of that car.
Yeah.
That would be my view. Tech turned on. Was there any other questions that you noticed? Because probably the next thing we should get into is what questions people have for Elon at Battery Day. And I have a list that I can go through to kind of get people's juices flowing. Auto bidder is a game
I'm just
changer.
checking.
Yeah. With Panasonic having out a roadmap to increase energy density by 20% in 5 years, do you see any part of the Roadrunner cell or Maxwell tech being incorporated here? Yeah, I do. But not the Maxwell dry battery electrode part of it. I think the entire battery industry is moving towards higher levels of silicon in the anode, along with single crystal technology and higher voltages. So I think Panasonic would have headed that direction anyways, and Tesla is just getting there a little bit before everybody else, if they do what I think they will do. Yeah, it's probably time to get into because we've been going for an hour now already, actually an hour and a half. It's gone fast.
Yeah. Yeah, so I'm down. So if you guys have a chat, or in the chat, if you guys can put what questions you would ask Elon Musk if you were given the opportunity about batteries. And so the reason why we're doing it this way is because honestly, we might as well I don't want to get up there and ask a question about leather seats or something like that. I want to get up there and ask like a really good question. You know what I mean? So because I like I said at the beginning, I'm going to be able to go to the battery day, so the likelihood of me asking a question is fairly high, and so I want to make sure that I have a really good question here. So if you guys have any questions that you would ask Elon Musk, go ahead and put that in the chat.
And I can throw some things in. Yeah, we don't want any questions about vegan leather steering wheels. As much as I appreciate the heart behind that comment, it was funny to see that 2 years in a row at the annual meeting. My view is obvious questions such as cost, energy density, charge rates, and chemistry. Hopefully those will be covered by the presentation. One of the questions I have, the first one is, what's the next target after $100 per kilowatt hour at the pack level? And are you able to provide a goal for when you expect to hit that price point? Nick Butler, Model 3 and Model Roadrunner sells when? One thing Elon did note a year ago is that the Model Y and the Model 3 wouldn't be getting a plaid version. From memory, I think he wrote a tweet about that. I did make a full video on how I think the Model Y will scale. And that is, I think it'll use existing supply lines because there's no sense in it disrupting those existing supply lines. Continue to ramp that. And then, much like they did with the S and the X, the S and the X are still using an 18650, and the 2170 has been around for years. And that's because I don't think Tesla likes disrupting an established supply line that's profitable. And I think that's why they're going to skip a generation. I have a feeling the Model 3 and Model Y in the US are going to continue to use that chemistry, but I think in other countries, they might use the Roadrunner cell chemistry in the future. But I'll put that down as a question. And I'll actually go a little bit more broad. Which vehicles will get Roadrunner? Now,
do you still plan on getting into the mining industry? That's from EV Stock Channel.
Okay. Plans for mining. Now, I don't think Elon will answer the question about when will other vehicles get Roadrunner, because that's the Osborne effect that would kick off
I think he would go in and be like, well, we do plan on upgrading the batteries over time, but we plan on rolling in upgrades over the next 4 or 5 years. Like, one of the things that was brought up, like, who was it? I think this was Elon with Sandy Munro on the Third Row Tesla podcast. They asked him when they think the Model 3 would get the stamping press on the back end done to it. And he basically said, oh, no, well, there's a lot of work that would have to go into that, so it's not going to be for a while. And so I think it would be something like that, of like where he kind of doesn't really answer the question exactly, just because it could have a larger negative impact than I think he would want if he said, oh yeah, no, 2 years from now we're going to upgrade all our cars so that they're way better than the current version. You know what I mean? Like, I just don't think he's going to go out there and say that unless it's going to be like really soon.
Yeah, and my view is that the way that you'll avoid the Osborne effect is you only put it in vehicles that are in other continents, or vehicles that are new model, like the Cybertruck, Roadster, Semi.
Exactly.
Because that way there is no Osborne effect because the vehicle doesn't exist yet. Now there's a question about lithium titanate. I don't know, honestly. But I've added that to the list here. Basically, I think a titanate anode would last a lot longer. And I think that might be a potential for, well, I don't know, because I don't know the voltage range of a titanate-based cell. I don't know enough about it. But I do think lithium iron phosphate is the way to go for energy storage after that interview with Shirley Mung, because that's one thing she specifically said, is that lithium iron phosphate, in her opinion, is probably the best option right now.
Mm-hmm.
And it's also long lasting. I think it's at least 10,000 cycles, something like that. Your sound hasn't died. We're just reading through comments.
Yeah.
Somebody asked, what questions do you guys have already? I have a list up here. I'll start reading through those. I'm just going to catch up on the comments. What battery cost does a Tesla need for 20K Model 2? That is a good question for Tesla, not me, because it comes down to the cost of the whole vehicle.
one's an interesting question from Brock Ludolf. He basically says, "What do you see Tesla expanding their products into marine, jet ski, boat applications?" Now, I have an interesting thing about this, but less with the jet ski and boat, like lake level applications. I almost imagine this more as, when are they going to start really bringing in batteries and large scale electric motors for ships that are actually transporting back and forth materials across the ocean? Because I think that does play a pretty big role, thinking about a big picture compared to smaller boats. So the question is, almost, do you see yourself expanding into other applications such as ships or areas like that where it's because most of those things are like diesel powered, aren't they? And it's not very clean diesel.
It's bunker fuel.
You know a lot about ships.
They call it bunker fuel. Bunker fuel is this really dirty ass diesel. It's just, I think shipping creates as much global emissions and pollution as the entire vehicle fleet combined. Something ridiculous like that. I'm not sure on the number.
Yeah,
but
that's what I mean. And so if that's if his end game is to be able to cut down on greenhouse gas emissions, then the logical step is you have to attack the areas that are producing the most greenhouse gas emissions. So I think actually asking a question about that would actually be a really good question. So thank you, Brock.
All of that. I think what we're getting at here with an E-Super VTOL and these ships, I think you're getting into part 3 of the master plan.
Yes.
Because it's like, what, every 10 years that they do another master plan? I would imagine that would be down the road.
Coming up pretty soon.
Yeah. After they get it tackled, I think probably, another few years we'll see a master plan part 3. 12. I don't know how to say 3 in French.
Yeah, don't look at me.
Partnerships. There's a lot of questions about partnerships. I'll just put it under a broader heading of partnerships. Sometimes people don't like to reveal the partnerships from raw materials and things like that. So I've avoided a lot of questions about partnerships. Those are more investing type questions for me, as far as like what other companies you might want to be invested in, which I'm really curious about. But for me, this day is about Tesla, and I want to know what they're going to be doing in the future. So I've targeted most of my questions for that, and we'll get to those after I work through these questions.
So I'll just say thank you to Ash for the $50 super chat, and the dude chilling out on the rocket or the firework.
Oh,
who eventually explodes, it looks like. So bummer for that dude, but yeah, thanks.
Awesome, thanks, Ash. Yeah, sorry, I just now got to that comment as somebody to read through. Battery Bulletin jumped in and said the voltage is around 2.5 volts for lithium titanate oxide, which I think is what LTO stands for in LFP. So, yeah, it looks like the voltage there would be pretty low. With batteries, there's always a trade-off decision, so I don't think it's something we'd want to cover as a question at Battery Day. So I'll remove that one. There we go.
And then there was 2 questions on that basically say, Elon, do you foresee licensing Tesla's technology? And I think that's going to be definitely a yes. The big problem with it right now is that they're limited on the amount of cells that are existent right now. So the biggest thing that they have to move out of the way to do that is produce cells.
Do you mean
that's why I think? Oh, go ahead.
Do you mean licensing the factory lines, or do you mean like selling batteries to people? Because my view is
that's a good point. That's a good point. Go ahead.
Yeah, because in my view, in which I covered my like original battery series, is like, where will Tesla get the most bang for their buck in terms of licensing? Because if they license out these cell lines to other people, they need to produce that equipment. And not only do they need to produce equipment, they need to provide support for that equipment, training for that equipment, and perhaps even like supply lines for that equipment. So would Tesla's energy be best spent working with engineers from other companies or their own company? So that's just my thoughts. I'll continue reading here.
Yeah, I think, and yeah, that's really the big question is are they going to partner with someone or are they going to sell? I think they're going to sell to people. And I think like there's a lot of comments on like, well, are they going to sell to like Arcimoto and stuff? I think they're going to establish like a baseline cost where they're going to, if someone wants to, basically anybody can buy a certain number of their cells for a certain cost. That's what I'm imagining. And they just have to specify how many, and that's going to be the cost. And then I think they're going to help out a lot of the smaller companies working on things on the side. Because like, yeah, big one, construction industry can't get enough cells to produce their like electric construction equipment. Like Arcimoto, a lot of these startups have trouble getting cells. I think they're going to really open up a lot of doors for a lot of other industries. Yeah.
Thanks to World is Our Barnacle for joining. And once again, thanks to Real Talk for the super chat and the question about does he foresee licensing Tesla's tech? Now, I'm hoping a lot of people get to ask their questions before you, because I think other people are going to ask that question. If not, then we'll add it to our list. But I have some questions that I think are a bit more juicy that I've been brewing up for a couple of weeks now. I'll just catch up here. Where are the battery parties in the Fremont area? That's from Eric the Goat Guy. Thanks for the super chat. I don't know where the battery parties are. I wonder if Galley and what's his name? The guy that runs the investing company that talks like a surfer.
Oh, Ross Gerber.
Yeah, Ross Gerber. Like, oh, batteries,
yeah, no, I met
man.
them.
Yeah. Yeah, you went to one of the parties, didn't you? You went, that's how you met
Yeah,
Galley.
I went. Yeah, I got to meet Galley down there, yeah. At the one before the Cybertruck unveil. I didn't get to go to the Cybertruck unveil, but I did get to meet with them. And like Viv was there. I don't think K10 was there, and like basically the whole third row was there. But yeah, that was cool.
Well, the voltage question. I have a feeling that they're probably gonna, if they're talking about, like a couple weeks ago, like Elon said about the whole core architecture, hopefully they cover any questions about voltage, new battery system, etc., all in one hit. But I'll put voltage down as a question mark. It's something I'm curious about. That's from Nick Butler. But I haven't gotten deep into yet. Andy Towers asks if you've met Viv.
I didn't, because a lot of people went up and started talking to her at that day, and I just didn't get a chance to. So I just wasn't, yeah. But I would have.
Okay. Well, Mike D asked the question, will Tesla continue to decrease vehicle retail costs? And if so, will they provide a projection for those cost decreases? I doubt they'd provide a cost projection. Once again, Osborne effect. They're not going to tell everybody that the cost of the vehicles is going to reduce. They'll just reduce the cost over time. And Elon has said this. He thinks their vehicles are too expensive. The entire goal of all this is to continue reducing the cost and democratizing this technology. That's been the whole thrust of the company for about 12 years now. I think they'll continue down that path. Past behavior is often a pretty good indicator of future behavior. I doubt they'll tell us when, though. I'll get to my questions that I have here. So the first question is, what's the next target after $100 per kilowatt hour? What's the energy density at the pack level? Because this will tell us not only how much the cell is improved, but how much the pack is improved as well. Any plans to combine lithium iron phosphate with Maxwell dry battery electrode? This could, with that combination, with Maxwell technology and lithium iron phosphate, we could potentially see batteries that are at a low enough price where you could do an economy vehicle for below $25,000 or about $20,000. So that's why I asked that question. And that also for energy storage, that'd be great. You're really getting into the meat of energy storage at around $60 to $70 a kilowatt hour at the pack level, which would be much lower even at the cell level. Is there any trends towards synthetic or natural graphite in your lines? This one is kind of an investing question, but it's also lets us know the quality of their technology. If you can use a natural graphite and get your natural graphite for half the cost of synthetic graphite, that bodes very well for the future cost trajectory of these batteries. And also, the people who are interested in Novonix or Tolga, it'll give you an insight as to where the market's headed. And what I expect he'll say is, you know, it's use case dependent. Like the energy storage might use synthetic where the vehicles will use natural. Or they might use a mix in both of them because each of them have good qualities. Will the switch to single crystal cathode add cost to the battery cell? If so, how is additional cost justified? And will the cost of single crystal cathode be as low as a conventional cathode material? What I'm getting at with this is the reason why I think Giga Nevada isn't moving to single crystal immediately and getting that 20% energy boost. I think it has to do with the cost of that single crystal cathode. They can keep driving that down, then we'll see higher energy density cells across all manufacturers sooner.
Mm-hmm.
When do you expect we'll see our first Terafactory? That will be very enlightening, because if it's, you know, within
that's the big question. Is I think the biggest question of Battery Day is how long until you can hit a terawatt hours, because they said in like, it was like an earnings call last year, they were like, oh yeah, we're going to go to a terawatt hour, and then like the next one they were like, oh yeah, we're planning for 3.2 terawatt hours, and it's like, oh well, when? Because that plays a huge role not only in like investor valuations, that plays a huge role in like just give us an idea on the technology and what they're at, because the sooner they can get that going, the better. So what was your projection again on when you think they were going to hit a terawatt?
Well, I think their goal is, my goal for them is 2 terawatt hours of annual production by 2030.
Okay.
That's just based off growth of automotive. But the thing is, one thing I've neglected with my channel is energy storage. The reason for that is because it's so small compared to the autos. But they could ramp much, much, much more quickly with a Roadrunner line if they can pull the materials out of the ground fast enough and feed them into those machines in the factories. But I think you grasp why that question is so important, because it tells us about everything. It tells us about their supply lines. It tells us about their confidence in their ability to scale. Kind of gives us a timeline for the entire valuation of the company. So to me, that's the most important question.
Especially if we do get a concrete, or not even a concrete, just an estimate on what their cost per kilogram is now.
Yeah.
Because then you could just multiply the battery cost times the amount of batteries they produce and get a good estimate on when they're at that level, how much they're actually going to be just spending on batteries, right? And then you take that and say, okay, they're going to mark that up, and there's going to be a certain level of other cost and then profit on top of that. But that'll just give you an idea on their revenue, like just a basic idea on their revenue. So like at $100 per kilowatt hour, it's like $100 billion per year if they can produce a terawatt per year. You know what I mean? Like once you're at those levels, their current valuation makes total sense. So obviously stuff's going down, other stuff's going up. That's just a really rough estimate, but it's still like that is going to tell us a lot.
Yeah. My view.
So I think that's one of the things we're going to bring up. Go ahead.
You can finish if you want. I'm just excited.
No, I was basically done. I was just summarizing. You're good.
I was just getting excited about an idea. I haven't done any. I did one video in the past kind of looking at the valuation of Tesla. I took it down. There's been like 2 or 3 videos I've done in the past because I took it down. It didn't really align with the channel. But one of them was having to do with the valuation. But my view is that each terawatt of capacity, if Tesla was strictly focused on manufacturing, nothing else, and they were just a battery producer, we're not talking about vehicles or anything like that, that for each terawatt hour, that's $1 trillion in market cap. So, and this is why, like my view is Tesla should be $2 trillion in market cap by 2030, because I expect them to be pumping out 2 terawatt hours. So if they can hit a terawatt hour much sooner than that, then it gives you an idea of the valuation. So that would be my top question. What I can probably do though is on Twitter maybe run some sort of poll and have people rank these. The next question, there be another battery day in the future for breaking 400 watt hours per kilogram? I doubt there would be. I don't know if that
I don't think
question's
so,
relevant, but I'm half and half about that
because
question.
I think they would be more of like an unveil, like a straight up, like, because if they are able to hit that number and their goal was to get, like, he already said he wants to do the VTOL, you know what I mean, and he would unveil something that proves out that technology. That's why I think one of the things that's going to happen during this battery day is I think he's going to. So I personally think he's basically going to roll out the Plaid Model S and be like, "This is the Plaid Model S. It can do this, this, and this," and read out some crazy specs of like its speed, its lap time. You know what I mean? It's like all, like, go down all this stuff, and then turn around and say, "And here's how we can achieve that in this car," and then go over the battery stuff. You know what I mean?
Mm-hmm.
And then go over, okay, well, we can achieve this by doing this. We can achieve this by doing this. We can achieve this by doing this.
Yeah.
That's kind of what I'm hoping happens. We'll see, though.
I'm like, I was having a chat with Elon last night about this, and to me, I don't think it's worth speculating what they will or they won't cover. But the reality is, we're going to have to adapt to whatever he's talking about, and I want to make sure we're prepared for whatever direction he goes.
That's definitely true.
Lotta Thomas asked, Department of Energy, Department of Commerce, Department of Defense, and Department of State launched the Federal Consortium for Advanced Batteries. What is Tesla's role? Well, I think the consortium, I don't know whether you say it's consortium or consortium, but
it's the same thing to me.
Tesla is involved in the Battery 500 consortium, which I think is related, because I think that one's also has strings with the Department of Energy. It's not a question that I would ask them at Battery Day. It's more something that I would have to investigate for video, something that I could maybe, a question I could ask the battery researchers I know, and if they could give me any insights. I've heard of it. I know a little bit about it, but it would be a topic for a video. Nickel contracts. I'll finish the questions that I had here. Soteria. I'm wondering if Tesla's going to go for a Soteria current collector. I doubt they would comment on it, but Soteria current collector, I don't know if you saw the interview that I did on that. Did you see that? Okay.
I don't know.
That would have big implications.
I'll rewatch it after this.
Basically, the Soteria current collector effectively makes a liquid electrolyte battery very close to the same set of benefits that you would get with a solid state battery. But all you
that was the one with the really high safety, right?
Super high safety.
The safety one? Yes. Okay. Yeah, I did watch it then.
Yeah. That's right. And what that also does, it allows you to reduce the amount of, I think earlier we were talking about the weight of the electrodes versus the weight of the active material. This would allow you to reduce the weight of that inactive material and make the current collector cheaper, which would also increase the energy density. So I don't like asking questions about specific companies, but that would give us some really good insights into where Tesla's going to head for the next 10 years. Because if they have a battery that's effectively safe without solid state, that also increases the energy density, man, I don't know whether they'd need to shift to solid state and invest all that capital for another good decade, 15 years. They could just run their current lines into the sunset. Okay. How does Maxwell DBE affect cold weather performance? I hope they cover charge rate. I think that's implied, but cold weather performance is something a lot of people are concerned about. Lithium plating, etc., in cold weather. And Maxwell DB might be able to help with that.
Yeah, so I think one of the questions that I was kind of thinking of in my head was basically, you're using the cells on the prototype starships, Elon. So I haven't written it down, so I don't know. So how do you see how does low temperature affect your design? Like, are you designing some of your cells so that they can work in low temperature environments such as the moon or Mars? That kind of thing, something like that, where it's like almost asking basically, we know your end game is Mars, so and you're already using your batteries in your starships. So how does that kind of technology play a role into developing your batteries now that, because the big thing is that one of the big announcements that they were going to make at Battery Day, and they just never really got to make the announcement, was that they were going to start producing their own cells. Pretty much everybody kind of realizes that they're going to start producing their own cells now. So because of that, I think now we can go in and say, okay, well, now that you're producing your own cells, how does space-based applications play a role into that in the future? Are you designing it for that, or do you even need to design that for that application? Because like maybe you're going to design the packs to do better at dealing with heat like thermal mitigation, stuff like that.
That would actually be one of my top 3 questions. Tesla has got to be thinking about batteries for SpaceX.
Mm-hmm.
And there's no sense in them buying the batteries from anybody else when they can just make it themselves. So it would probably be number 3.
I think Elon said that in a tweet. They were like, "Oh wow, you guys use SpaceX batteries?" And he was like, "I'd be embarrassed if we used anybody else's."
Yeah, so they might have something specifically designed for space. Okay. So for me, the top question would be the Terrafactory one. I'll leave it to you on the day. I'll load you up with these questions, and then just, it would be awesome if what happened at Battery Day is what happened with Galileo Russell on that the first investor call that Gally was on, where Elon said, "Okay, well,
you just got to ask like 10 questions."
yeah, just keep going. I like your questions, so keep going. I want the questions to be so good where Elon's like, "Ooh, this has got me excited. I want to answer some more of this guy's questions." I think that about covers it. Do you guys have anything else you'd like covered off? Or is it time to wrap up? Looks like it's time to wrap up. I think maybe we've put people to sleep. I don't know how many.
The one thing that would be cool, and I'm just going to say this out, my wild card prediction on what they're going to announce for Battery Day, or not announce, but one thing that I imagine they'd roll out would be the Roadster SpaceX edition. Now that's total speculation, but he's teased it a lot, and they haven't shown a single thing about it. You know what I mean? Now I don't think that's likely at all, but I mean, if they do have a really big improvement in energy density, that could allow for that to work better, and them to display it, say, "Look, this is it in a car. Look at it fly, like it'll hop." You know what I mean? But I don't know. That could be.
I don't know. There's so many things that they could release at Battery Day. And this is what I was having a chat with Yvonne about last night as well. I
think I froze.
Oh, did I freeze?
Yeah, no, I froze.
Okay, yeah.
Whoops.
Was that the last big announcement we had was about a year ago at Cybertruck, and I think Tesla has a lot lined up for us at Battery Day. At least I hope they do. And somebody made a question. Please ask a question about LFP for energy storage. I think LFP would be one of my things in the top 3 as well, if they don't already cover it, because LFP is one of the most important parts of their strategy, because it opens up a huge amount of supply at a low cost. It seems just to hit the mark right now.
Combination. Oh, and I did have someone just asked about metal air battery packs. And we did talk about that towards the beginning, but I guess I can overview that real quick again. Basically, since 2010, roughly, Tesla's been filing patents for metal air battery packs. And metal air battery packs basically have a stupid high energy density. And the reason is because if you look at batteries from kind of a first principles analysis, you have the oxidation reaction and then the reduction reaction. So you have oxygen, who kind of gives up an ion that gives it to lithium, that causes it to jump to the other side into the anode, from the cathode to the anode. And so you store the oxygen in the chemical combination. So like NCA is lithium NCA oxides. So the question is, why are you having oxides, or why are you making all that extra mass in there when you can have the mass? There's oxygen in the atmosphere around you. Why are you carrying that around with you permanently in the battery? What if you just sucked it out of the air and put it into the cell to generate electricity? And I think basically they've been filing a lot of patents for it, and they've been doing a ton of research into it from what it looks like in the past. And they filed a patent for it at the first of this month. And that it was interesting because basically that patent basically said that it would actually create safer battery packs, because metal air batteries don't have oxygen actually necessarily in the cells themselves. So if there was a fire, you could eject the heat through the metal air battery pack, and it'll basically it won't light on fire. It'll just absorb the heat and allow for less heat to spill out into the outside environment. That's what the patent was about. And the patent was filed by a guy named Wes Arthur Hearn, I think. And he used to work at Tesla, and now he actually works at QuantumScape. But he filed a bunch of patents on metal air batteries back. But he was also the person who was in charge of designing the second generation Model S, Model X battery pack, according to his LinkedIn. So if that could be pointing towards something, but I think Battery Bulletin mentioned that it would be like 20, 30 years or 30, 40 years away from being around. There's a lot of issues with metal air batteries that they'd have to work out. But if they can do like a hybrid pack between half of it lithium, half of it metal air, they could actually get higher energy densities on the pack level, because you'd be able to basically be hitting like higher levels. Someone mentioned Fred's battery cell. We totally forgot to talk about that.
Oh God, yeah. Let's. I'll pull that up.
What are we doing?
I'll bring that up.
Yeah.
Here we go. Yeah, there it is. Basically, and here's what's interesting. If you zoom in on it, there's a 54 on it. I think that stands for 54 millimeters, and this was pointed out to me by Roger Starkey, who's usually. I'm surprised I haven't seen him in the comments here. Maybe he's asleep for the night or something. But yeah, 54 might mean 54 millimeters. It looks like about 54 millimeters wide, and if that's say 54 millimeters wide, you'd be looking at like 100 millimeters tall. I don't know if that's what the 54 stands for. To me, it looks between 40 and 50 millimeters thick and about, 90 to 100 millimeters tall. This is bigger than I expected. The implications of this, I would assume that the volume of that is about 5 times the volume of one of Tesla's current 2170 cells. If it's 5 times the volume, that means you need 1/5 the number of cells that you have to stuff into the battery pack, which saves a ton of time. I don't know if anybody here has ever done a paper route, but just imagine all the time it takes you to roll up those newspapers. Imagine if you could roll up 5 newspapers at once together. It's 1/5 the time. So if you have Maxwell lines that are cranking out cathode material and anode material applied to electrodes at 2 to 5 times the speed of a typical production line, you'd need a way to be able to roll those up and stuff them into a cell more quickly. And that's what this would allow. It also potentially would allow higher energy density, because you'd have less packaging material, because you'd have greater internal volume with something like that. There's also
do you have the other picture with you too?
Yeah, I'll bring that up. Cool. And this is interesting. There's like a cap on it, a plastic seal. I don't know if that's just like a protective seal.
See, are we sure that's not toilet paper? I'm just kidding.
I have my toilet paper up there. But yeah, it looks like he peeled all that off for the other image, because there's this, which if you're going to insert this in a pack with cell to pack, that flange, you just fold those flanges over and just weld it on, and boom. That's your cell to pack. That would be fantastic. Oh, and B.R. Cooper said it's about 6 times the volume. That would be a big advancement. It'd save them a lot of time, cost. I'm excited. I'm really excited about Battery Day. I need to find out if I'm how far away I am. I can't be 100% right. I've got to be a certain percentage off. If I'm 50% right on what they reveal at Battery Day, I'll be over the moon. Because I think before I started talking about single crystal cathode that's coated, thicker cells, thicker cathode, before I started talking about any of this, I don't remember anybody really talking about it. You were the first person I really talked to that seemed to be digging into these parts of the battery and cell architecture.
Yeah. I think someone's calling me on my phone. It's like buzzing.
All right.
It's all good though. And then just to be clear with the metal air batteries, I don't think it's probably not going to happen, but I just think it's important to bring up just in case it does. Just because there's a ton of problems with it, but they just have so many patents on it that it's just like might as well bring it up just to we mention it. So like if it does end up coming out that's what it is. Yeah.
Yeah, and once again, this is low probability. It's just something a lot of people are interested in right now because it's come out in the news. And Nick Butler, thank you for the super chat. I'm just making my way through this. Yeah, you rock too. I love you too, bro. Thanks for your continued support of the channel. Nick's been supporting me since the beginning. Oh, the place that I got that battery cell image was on Fred from Electric, his Twitter account, and then I also retweeted it. There's a lot of people that he's blocked, so I also posted the pictures separately because he must have blocked hundreds of people. The number of people that say they're blocked and they can't see it. It's amazing.
Well, yeah, because he had beef with I think Omar.
Yeah.
The two of them called each other toxic, and they got into a little bit of a Twitter spat.
A Twitter twat?
It'd be like that sometimes.
Sorry, that's a bad word. That was a slip of the tongue. So, yeah, there was a Twitter spat between Omar and Fred.
All right, so you want to go ahead and close it out?
Yeah.
Then?
I think that about covers it off. Sweet. Well,
Awesome.
Thanks everybody for tuning in. I think we're pretty well prepared for Battery Day. We'll take a look at the questions that we have on this list and try to rank order them for Ryan before he goes. On the day, I'm going to start the live stream when the investor presentation starts. There's probably going to be a bus, I'm assuming, that takes Ryan from the investor presentation, the yearly meeting, the annual meeting, and takes him to the Cato Road site, is what I'm assuming. Now,
well, they're in walking distance from each other.
All right.
Like they're right next to each other. If you look at it from like an aerial view, I mean, maybe it's far because I mean it's a manufacturing facility. They always look smaller when you're looking at it from aerial view, but I have a feeling they're just gonna have us walk. In fact, in the invitation, it said to wear comfortable shoes.
Yeah.
So I think they're just going to walk.
What I'm going to do is I'm going to keep the Zoom chat window open during the whole thing, and then if Ryan takes us along on the journey, if it's not a pain in the butt to keep his Zoom on walking there, then yeah, we'll make a call on the day. I don't know if it's worth taking everybody on the walk to the facility. We might just have an intermission or a break while everybody's walking there, and then when it comes back up, I'll throw it on the screen. And then after that, we'll have a chat afterwards. I think Yvonne from the EV Stock channel will stop by the channel. We're going to have a chat with Ryan. Mm-hmm. Ryan's also going to be snagging some video for what he can take videos of for B-roll for the channel. And that's about it. And Asimo, thanks for the super chat. That's awesome. He's managed to hit every one of my... Asimo 3089, he's managed to hit every one of my live streams so far, which is impressive because they've all sort of been at different times. And Origami Cybertruck, thank you too, man. I appreciate it. Yeah, yeah. I'm not going to make him hold the camera for 30 minutes while he walks there.
Oh well,
You have a toy.
so I got one of these camera. Oh, it's like disappearing. Where? How do I get it to not disappear? I got one of these things.
Put it in front of your chest. There we go. Yeah. Oh, so you got a gimbal and out.
The camera stabilized.
Sweet. That means
so.
Yeah, that means the video.
So that way we can at least get some stable footage. Yeah.
That's awesome.
Hopefully that'll help. And this is actually also a battery pack too. So Nick Butler, I have you covered.
Sweet. Awesome, man. You're all set up. That was one thing I was curious about because I was like, oh, the B-roll might be a bit shaky, but it'll be better than the B-roll I currently have, which is none. So yeah, if you have a camera stabilizer, that's sweet. Excellent. I think we're all set. I think it's time to say goodbye. And
sweet.
Thanks everybody watching. Thanks Nick Butler. Yep. And thanks
everybody for watching.
Yeah, thanks Battery Bulletin for being a bit of a referee because we're Battery Bulletin is actually a battery researcher who actually he actually knows a lot more about this stuff than we do. So it's good to have a bit of a referee there.
Yeah, because we can definitely get carried away by our hype. So it's good to have someone who can keep us grounded.
Yep.
Thanks, Battery Bulletin.
Sweet.
All right, thanks, guys.
Yeah. Okay, I've ended the stream.
Cool.